What is the diameter, x, of the larger circumscribed blue semicircle? Line and circle constructions, Pythagoras' theorem, angles in the segment theorem and basic arithmetic, algebraic operations are used to solve this question. Solution. Label points A, B, C, D, E, K and G. Where O, E, and Y are the centers of the small, large and larger semicircles, respectively. Join line O, E, and line CE. Since line O, A equals line O, B, which equals 2, and line C, E is equals 3. It implies that line O, E equals the sum of 2 and 3, which equals 5. Also, line O, Y equals R minus line O, A, which equals to R minus 2. From right triangle COE. Using Pythagoras' theorem. The square of line O, C equals the square of line O, E minus the square of line C, E. Substitute values. We have that the square of line O, C equals the square of 5 minus the square of 3, which equals to 16. Take the square root of the equation. Line O, C equals the square root of 16, which equals to 4. But line B, C equals line O, C minus line O, B, which equals to 4 minus 2. The result equals to 2. It follows that line O, Y equals R minus 2. We call it equation 1. Label point T and join line TE. From triangle EOC. Let angle COE equals theta. It implies that line OC divided by line OE equals 4 divided by 5, which equals to cosine theta. We call it equation 2. Consider triangle EYO. Use cosine rule. The square of line YE equals the sum of the square of line OY and the square of line OE minus 2 times the product of line OY and line OE times cosine theta. Substitute equation 1, equation 2, and other values. We obtained a new equation for the square of line YE as shown on the screen. Simplify it so that the square of line YE equals the square of R minus 12 times R plus 45. Take the square root of the equation. We have that line YE equals the square root of the square of R minus 12 times R plus 45. We call it equation 3. Label point P. Join line GT, line PT, and line FP. It follows that line EG equals line E, F which equals 3. Angle TG equals alpha, which equals angle FPE. Reconstruct the given semicircle as a circle, as shown in Figure 1b. Add the details we derived in the above figure of semicircle. We use the property of similar triangles. It implies that line ET divided by line EG equals line EF divided by line EP equals tan theta. Substitute values. We have that 1/3 of r minus the square root of the square of r minus 12 times r plus 45 equals 3 divided by the sum of r and the square root of the square of r minus 12 times r plus 45. Cross multiply. We obtained an equation in R as shown on the screen. Open brackets, multiply out and simplify. It means that 12 times r minus 45 equals 9. We combine like terms. 12 times r equals 54. Hence, r equals 54 divided by 12, which equals to half of 9. Therefore, x equals 2 times r, which equals to 2 times half of 9. The result equals to 9 units. Second method. Join line KY, which is equals to the radius r of the blue outer semicircle. The value of line YE is shown on the left-hand side of the screen. After substituting the value of r equals to 9 units. Consider triangle YEK. Use Pythagoras' theorem. The square of line YK equals the sum of the square of line YE and the square of line EK. Substitute values. We have that the square of line YK equals the square of r, which equals to 81 divided by 4, after simplification of substituted values. Take the square root of the equation. Hence, r equals the square root of 81 divided by 4, which equals to half of 9 in units. This implies that the length x equals 2 times r, which equals to 2 times half of 9. The final result is equals to 9 units. Therefore, x equals to 9 units.